test next week over this chapter, not an easy test. That's true. This one's short. So if I say this one's not easy, then what's that tell you? It's gonna be really hard. So if you, I'm hoping. Confidence intervals for variance and standard deviation. I think this is a little more important than the other stuff, because when you're talking about this, when you're dealing with the standard deviation, you can sort of take things. If I wanted to, maybe for the copy machine downstairs, I wanted to go through and I wanted to take this as my sample. And I go through and I somehow have a way to rate the darkness that the copy machine's putting on this to see if our copy machine's wore out or not. And I go through and I take that one, I take that one, and then I find the standard deviation. I can see how far off we are one way or the other, whether it's too dark or too light. And then that'll tell me if we need to do something to the copy machine. We talked last time about the boozles. And if you're making a boozle for a car, you need to know that when you're producing that part for the car, or part for what, it doesn't have to be for a car, it could be for whatever. When you're producing that, they all got to be within a certain standard deviation of exactly the same. And if they're not, then when you start selling them to people and they don't work, are those people going to come back to your company and buy again? No, they're going to go somewhere else where it's better. Okay? Jesse works on his trucks all the time and stuff. A lot of times you get stuff on automobiles where you'll have a fine thread bolt or a metric bolt or a standard bolt. Well, when they produce those, you're really, really hoping that they're exactly the same every single time. Because if they're not, you get that one bolt that all of a sudden won't go in to hold, whatever on the automobile, and it screws everything up. Stuff like you were talking about a hub, they usually have those, and if that was old and rusted, it probably didn't have it, but most hubs have the little lock screws that come out of the factory with them, and if you try to replace those, usually the ones you get don't work right. They don't lock back on there. Most people don't even bother to replace the lock screws when you put a hub back on, because you just leave it out. But they don't work right. No idea why, they just don't produce them right. So standard deviation, that's telling us if we're within a certain range to where we know this will actually be okay, it'll actually work. Again, you wrote down some of this last time, so I'm going to go through it sort of quickly. Variation we see in the sample will be your best guess. Sample is variance is S squared, remember that, or sigma squared. Standard deviation is S or sigma. Chi-squared. This is the formula for chi-squared. We really don't ever use this formula, or not this chapter at least. We're not going to use this formula, but that tells you the formula to find chi-squared. We do have to use DF, again, degrees of freedom, n-1. I gave you guys the charts last time, right? So for the chi-squared chart, and hopefully you wrote chi-squared on the top of that chart, and normal on the top of one of the charts, and T on top of another, so you can keep the three separated and know which one you're supposed to use when. The chi-squared is your distribution. The chi distribution is different. Again, instead of looking like our normal distribution, it's a little more humped. So the normal distribution might be something like that, where it's more symmetric. The chi distribution is skewed to the right. It's got more of the hump on the left-hand side. That's just extra. With the chi distribution, chi distribution is number one, chi-squared's always got to be greater than 0. It's never going to be a negative. It's always a family of curves. The higher your n is, the higher your sample set is. The more you got in it, the closer it gets to looking like a normal curve. The area is always 1 under the curve still. All chi-squared curves are positively skewed or skewed right. We talked about that. This is the key thing. We want to find these two. Those are our critical points. So we want to find those critical values. We got to find those two, and that's probably the hardest thing. If you did some of the homework that you had that I assigned last time, that's the hardest thing, because normally we could find those pretty easily just by looking on the chart or whatever. These are a little harder. You got to do a little more work for them, and I'm going to show you a couple of those. So we got to find those. And what we're looking for those two, and we're actually looking for this area and this area, but to do that, the chart only deals with areas to the right this time. All the other charts that we've dealt with all the rest of the year dealt with area to the left. The chi-squared chart deals with area to the right of that value, that critical value. So when we're doing this, and if you didn't write this down last time, you might want to write these steps down. To find the chi critical values. Number one, you got to find your degrees of freedom, n-1. You got to find that first. Dalton's got these written down. There's like 3 steps here. He should be able to find this pretty easily. So you find your degrees of freedom first, then you find the area to the right of the two critical values. The way we find those areas, find the first area by doing 1 minus c. What's c stand for again? We've been doing the whole chapter. Confidence. So you're 90%, you're 95%, you're 99%, 80%, whatever it is. That's your confidence level that you're looking for. That's the way you find this area. That doesn't tell us the critical value, but it tells us the area. And we got to find that area first. To find the second area, the area from here all the way over. All we do is that right there. 1 plus the critical value divided by 2. Now what should be true about these two areas? Let's just make up something here. Give me a confidence level that we're looking at. One that we've used. 90. So we got 90. C is 90. That's just what I heard first. C is 95 or 90%. That's what we're looking at. You're going to plug that in here. So you're going to put 0.9 in here. What's 1 minus 0.9? 0.10. Divide that by 2. What's that give you? 0.05. So that means 5% of the area is in that little space right there. What's always going to be true about this second one is it's the rest of the area. So if we have this, you could do this and it's going to give you the same answer, but all you really have to do is take this and subtract from 1. What's 1 minus 0.05? 0.95, and that's what it's going to give you over here. Those are our two areas, and what we're going to do with those two areas is we're going to use the chart, that chi-squared chart that you got last time. We're going to use the chart with those two areas and the DF to look them up. Jacob, that make any sense? No? All right, so let's do this. Get the charts out. Get that chart out that I gave you last time, the chi-squared chart. Let's just make up something here. We got a sample. Give me a sample size that we're going to use. 6. So we use n is 6. We picked 6 people, surveyed them for whatever reason.
You do 6 minus 1.
6 minus 1, that's going to give us our DF, right? Our degrees of freedom. What is 6 minus 1? 5. So we have 5 degrees of freedom. All right, that's the first thing we do. We're going to use a confidence interval of 90%. All right? What we got to do with that 90% is we come down here and we put in 1 minus 0.90 divided by 2. That tells us one of the areas. That tells us this small area right here. Then we do the same thing over here, except instead of minusing 0.90, we add 1 plus 0.90 divided by 2. Well, 1 plus 0.90 is 1.9. 1.9 divided by 2 is 0.95. So we got those two. First thing you're going to do is you're going to use this 5 right here and this number and look it up on the chart. So we look on the chart, we go down on the side here, we go down to 5 and we want 0.05. 0.05 is like the 4th one from the right.
11.071.
So this critical value right here would be 11.071. I think that's what you said, right?
Yes.
That's that critical value right there. Then to find the other one, we do the same thing, except we use 5 and we use that number right there. So we go down to 5 and we go over to 0.95.
1.145.
1.145. So this value, 1.145. So now we have our two critical values. And if I go to this next slide, now we have those two from the chart. The right one, the one on the far right, we said was how much? What did it say? 11 point something?
11.071.
The one on the left?
1.145.
So now what we're looking at is we're on this chi graph and it looks something like this. That's not very good, but what's this R stand for?
Right.
The right one. That'd be this one over here, right?
Yeah.
So what's the number that goes along with this little critical value or this line right here? 11.071. What's the number that goes with this one? 1.145. So we're finding those two critical values and we had a 90% confidence interval. So what we're saying is we're 90% confident that all of our standard deviations and our variances should fall in that range right there. That make any more sense? So you got to use the chart. You didn't write down number 3. This is number 3 for the rules there. So just then I'll go back to this here in 1 second. So first thing you do, you find your degrees of freedom. Use these two little formulas to find your areas. Then you're going to use the chart, the third step. Use the chart to find your critical values. This is one critical value. This is chi squared right, chi squared left. Use the chart to find those two critical values. You got all that down, right, Jess?
Yeah.
You wouldn't lie to me?
No.
Does everybody have those 3 steps?
Yep.
Any questions before I go on?
No, sir.
Think you can handle that? You want to try one of those right now? We want to try one right now? Get the books out. Books out, I think problem like problem number 3. Wasn't the first one of those?
Yeah.
Problem number 3. So let's just look at like problem number 3, problem number 4, and we'll do a couple of them together. What do they tell us on problem number 3? Nothing? Make sure you have your calculator. Yeah, you probably don't need your calculator. Go ahead.
That C is 90 and N 8.
So this is almost the same as what we just did, isn't it? And they just want us to find the critical values.
So find the critical values. Yeah.
So we just want to find those 2 critical values. So when we're done, we're going to have the chi-squared right and the chi-squared left. Those are going to be our 2 answers. First step we do, we find the degrees of freedom. If you get lost on a lot of this stuff, this chapter, what might be the first thing you do? Find the degrees of freedom. What is our degrees of freedom this time? 7. How'd you get that? 8 minus 1. So you got, my pen was right, 7. So that's our degrees of freedom. We know that. Second thing we do, find the areas. To find one area, we do 1 minus, ignore that, 1 minus C divided by 2. To find the other area, we do 1 plus C divided by 2. What's C stand for again? The confidence level that we're looking at. What was our confidence level this time? 90. So with this one, we're going to do 1 minus 0.90 divided by 2. This one, we're going to do 1 plus 0.90 divided by 2. What is 1 minus 0.90 divided by 2?
05.
What's 1 plus 0.90 divided by 2? 0.95. Now, this is probably the hardest thing because this stuff really doesn't mean anything. It's not anything that we're going to use. All it is so that we can use our chart to find the stuff. All right? All this is telling us is if I look at my chi, I have 0.05 of the area from that critical value over, and I have 0.95 of the area from this critical value all the way to the right. That's all those 2 things are telling you. Once you have that, now you use the chart. So get your chart out. What's the first 2 numbers we're going to look up on the chart?
05 and 7.
05 and 7. So we're going to use the 7, the degrees of freedom, and the 05. And that's going to give us our chi-squared, the right number.
14.067.
Anybody else agree with Jesse?
Yeah.
Now, before I even do the left number, give me a number that could not be the left number. 15. Why not? It's too high. It's bigger than the right number. All right? The left number better be smaller because it's farther to the left. Now look up the left number. How are we going to look up the left number?
0.95.
0.95 in the set.
2.167.
Everybody agree with Jesse on that one? So what we're saying on this, if we got our little chi-squared graph here, one of the critical values, this critical value right here, is what number? 2.167. This critical value is the other one, 14. I know it seems sort of backwards, but the reason you do that, the reason they're backwards, is for what we're going to do with this next. It seems like, okay, we should find this one first because it's on the left, and this one second because it's on the right. And I get them turned around sometimes because usually we do everything left to right. But when we go to find the intervals, we want this one first and this one second. And I'll explain that as we get to it. Riley, that help any? Are you lying to me? Just because you're mad at me today because I've been mean to you?
I figured the 14 point whatever would be on the left because it's everything to the right. Right?
Now, it's, remember, you're thinking back to the area. So there's more area from here over, but this number is gonna be a smaller number because you're on a graph. Remember, you're always on a graph. So if I did something like this, what might that number right there be on that graph? It's not gonna be 2, is it? Because when we go to the right, the numbers get bigger. And that's
Count down.
not to the right. If we were counting down, we'd be going to the what? Left. That's why we have mathematical rules so that we don't. So with this, again, your left, your chi-squared left is your low one. Chi-squared right is your high critical value. This in here is your confidence percentage. So on ours that we just did, it was 90%. Do we want to do another one of those real quick? Yes, no, maybe?
Pretty simple.
So let's do, let's just do number 4. What do they tell us on number 4?
C equals 0.99 and N equals 15.
15?
Yeah.
First thing we're going to find is what?
Degrees of freedom.
Degrees of freedom. What are the degrees of freedom?
14.
14. 15 minus 1. Right, Sean? Now what?
1 minus C over 2.
And let's just put in C this time. 1 minus
0.99.
0.99 over 2. What's the other one?
1 plus 99.
1 plus 0.99 over 2. Do that real quick on your calculator. What'd you get? 0.005.
0.9.
Boy, somebody better be using their calculator. Because Jesse's trying to use his head and that worries me.
Yeah, 1.95. 0.995.
What should these two add up to again? 2 again? They should add up to 1 whole. So we got those. We got our degrees of freedom. Now what are we going to use?
The chart.
Now you use the chart. So grab your chart. We're going to find the right one first. So we're going to use the 14 in this. Somebody tell me the chi-squared right then. 1.319. Anybody agree with that? Somebody tell me the chi-squared left. What are we going to use to find it?
995.
The 995 and the 14.
4.075.
Does it make sense for those two to be what we got them down as? Yeah. 4's down here, low end, 31's up here at the high end. What percent's in the middle here? 99% falls in here. That's our confidence. We're confident that when we do this, that our stuff should fall in that range. Now, does this 4 and this 31 mean that for this problem, that our numbers are going to fall between 4 and 31? No, it means our variance and our standard deviation, 99% is going to fall in there, and we're going to go on and figure that out, how to find those intervals and what numbers go here and here for the intervals. So again, you're looking at this area. Now this area is really just a throwaway area because we're looking at that because it's to the right, but what we're really looking at is these two ends, the two tails. Right. How do we build the intervals for variance and standard deviation? Again, I think I said this last time. Don't write that one down. We don't use it. This one here is the one that we're gonna use. What's sigma squared stand for again? Variance. So this is how we're gonna set up this interval for the variance. Notice again, I'm writing them with the alligator mouse. All right, Carson, I'm writing them with the alligator mouse. Could we also write the interval with the parentheses and the comma? Yeah, and that's the way the book usually does it, and that's probably, I think when I've looked at your guys' work for this chapter, that's the way most of you do it too. Might be just the way Slater does it, I don't know, so. But that's the way that I've seen on your papers.
It is the way Slater does.
Easier way to do it, maybe.
I don't use Slater.
I know you just use Carson who used Slater because you're too lazy to even get on there yourself. Don't you see how that worked? That comedy timing, man.
Too busy.
Right time,
Right
right
get on
time.
there.
So on this one, what three things do we need to know on this to be able to set up both sides of this? We need to know n. What is n?
Number of your stuff.
Number in the sample. What else do we need to know?
Degree of
The
freedom.
no.
So,
Look at your variables.
okay.
We need to know s. What's s stand for? Standard deviation. So we need to know n, which is the number in the sample. We need to know s, which is standard deviation. We could know the variance, but if we know the variance, do we need to know the standard deviation? No, because if we know s, then we can just square it on the calculator. But if we know the variance, do we have to square it? So you got to be careful of that. If you're putting variance in there, do you square it? No, because it's already squared. If you're putting s in there, then you got to square it. What's the other thing we need to know? The points, the chi's, the critical values that we were just finding on those last two problems. You know those three things, then you can set this up. Do we have to know the one?
Yeah.
Write this one down here at the bottom. This is the same as what you just wrote down. This one, instead of the interval for variance, this one's the interval for what? Standard deviation. And all you do to find that interval is once you found the interval for the variance, you just take the square root of the two numbers you found.
You going over this twice so you know that we got this in our head?
I'm hoping.
I'm gonna get 100 on this next test. Just like all the other ones.
I would have believed you if you wouldn't have put that last sentence on there.
No, but I really am. This is easy.
And what's going to be the hardest thing on the test next week?
Remembering this, using the calculator.
I would think the hardest thing would be knowing what you're doing on which problem. Whether you're using a normal distribution, whether you're using a t-distribution.
It's all
whether-
done together.
Yeah.
Oh my god. I probably won't get on my go
Oh my.
I take back what I said. I probably won't get it on.
Find me a problem that you did on your homework. We'll do it next. So while I'm making sure everybody's got this formula copied down, find me one of the problems off the homework where you actually had to find the variance interval and the standard deviation interval. 11? 11 is probably a good one. Make sure you got your calculators out, because what do they give you on 11?
A chart.
A chart. If they give you a big long list like that, what do you got to do? You got to put it into your calculator. So get your calculator out. Nick, even though he's so tired, he's going to make sure he gets up, walks over here, and grabs a tablet, because his phone probably won't hold the charts, right, Nick? Jacob's looking at you like,
Yes.
And it is a safe.
He's like turned towards me too.
So everybody got the formulas?
Yeah.
Yeah. What's the air coverage, frontal coverage?
No.
No, they don't care. Once they get that old.
I wouldn't either, but. I've calmed down my old age, though. I really didn't take it back. I've learned, I'm much wiser than I once was.
Last year was just crazy.
It was. I feel upset last year. Yeah.
Number 11, on number 11, the first thing you're going to do, take your calculator, and if they give you a list, you got to put it in list on here. That works for everything that we've done throughout the chapter. So on number 11, let's see here, go to Stat, Edit, pick one of the lists. I swear I had this on the list. I didn't want to punch it in again. And start punching those in.
I'm gonna delete these 30 numbers that I got.
Go to a different list.
Oh, I forgot I could do that.
Make it easier. Just remember which one you put it on. I got it. I made my 10-year-old son punch it in for me as I read him off the numbers. Because this is boring. Shut up. He was sitting way across the table so I couldn't smack him at the time. When you get down to the bottom of the list, once you get those put in, how many numbers should you have in the list? 18. So make sure, like when I go down, if I go down one past my list, something's not right on mine. Should never trusted a 10-year-old kid, should I? Because he's got 88 in here. Oh, that's .88. Okay, so that is one. If I go down clear to the bottom, once I'm past the list, and I'm on the one that's just got the little dashes, my line down here should say 19. That tells me that I have 18 in the list above. So for problem 11, what were the three things that we said we needed again? We need N. What else?
Standard deviation.
S. What else?
Critical values.
The chi-squareds, right? So we need those three things. We actually need the chi-squared left and the chi-squared right. So we need four things if you want to count them that
What
way.
about the variance?
The variance, where are we going to get the variance from?
Square.
Square that once we know it. Do we know N?
Yeah.
Yeah, Jacob just told us a second ago. 18, so that's 18. Now to find the standard deviation, we're going to use the calculator. What you do is you hit stat again. We did this earlier this year. You hit stat, go over to calculate, and we want the one bars thing again. Remember when we were doing standard deviation and all that, and the X bar and everything? We're going to use that, one bars again. So you do calculate, one bars, put in your list. Mine was on list 1, whichever one you put it in on.
0.2532.
So S is what?
0.253.
We'll say 253, that's enough. Is that what everybody else got? Does that make sense to everybody, how we got that? So you gotta find that S first, you gotta do that one bars.
Mine didn't even give me
Gave you an SX then.
No, it didn't give
this.
me.
They gave me an SX, but there's no number next to it.
Sucks for you.
Go back and try it again.
You probably didn't have a
Go
little
to calculate. Yeah. Hold on. Oh, that's right, these calculators are different than the old ones, aren't they? I was using the old ones.
Check your list.
Why would it?
Start over, turn it off, turn it on.
Yeah, don't go, just follow along, but maybe here in a minute, go back down through and check your list to make sure something's not right in there. Anybody else that's got the new calculator, did it work all right on yours?
They must have forgot to put that piece in his calculator.
You found it earlier this year, so it shouldn't. So we do that, we got S. Now all we're gonna do, next thing we're gonna do, find those two. To find the critical values, 1 minus, oh, I forgot something up here, one other thing we need to know. 1 minus C divided by 2 and 1 plus C divided by 2. What did I forget that we need to know? The C. And then we also need the degrees of freedom, which we'll find here in a minute. What is our C? They told us in problem 11. They probably told us up in the top directions.
99.
99% confidence interval, that's what we're doing for each one? Didn't we just do that?
What?
Yeah,
99 one? What was this number?
it was 0.1, or 0.01 or something. Wait.
Maybe we better do it then.
It's
Oh, it's
0.0.
0.005, what was this number? 0.995. If you plugged in that 0.9 there, 0.9 there, and did the math, you would get that.
My brain-
Now, Jacob said we also need what?
Degrees.
Degrees of freedom. What is the degrees of freedom? 17. What are we gonna do with this and this?
Use that chart.
Use the chart. Somebody help me out with the chart.
My brain isn't working right today,
Dalton, you see how I skipped that one? That's that timing. See, I didn't say the smart aleck comments that came into my head. So we want to look at the chart. We got 17.05. What do you come up with?
35.718.
Anybody agree with that? 35.718? Yes, no, maybe?
Why'd you do that at 0.90 if it's 0.99 there?
It is, because I screwed it.
so. See, I told you.
No, you didn't.
Yes, I did. I said 0.001.
You told me, all right. You told me
And
your
you
brain
said-
wasn't working right.
You said maybe we should do it again. So maybe my.
Now,
brain
that, even though I messed up and put 90 up there, did that affect this?
No, I
We,
did the numbers.
we did these numbers, right? I just wrote the wrong thing down. So,
That wouldn't matter.
well, yeah, it does matter,
It's-
but I did the math like we were using .99. I just wrote down the wrong thing. So if we were using .90, this would have been 1 minus that, which is .10,
It was
divided by 2, which is .05, not .005.
Isn't it 0.001 or something?
No. Do it on your calculator, Jesse. Grab your
I
calculator.
trust you.
And they throw something at you. Alright, so we got these. We got that 35.718. That's a 7, not a question mark. How do we find the left chi value? 0.995 in the 17. What do you come up with? 5.697. Now you really don't need this, but if we were looking at the chart, at the chi chart, looks something like that. What's the critical value here?
5.6.
5.697. What's the critical value there?
35.
35 point whatever. All we need now is now we need to use the formulas. So what's the formula for our variance? Sigma squared. Oops, that should be a less than symbol, not an equal symbol.
That would be
N minus 1, what is N?
18
18 minus 1.
times 0.253 squared.
253, and remember here, this is where somebody's gonna make a mistake. We have the standard deviation, not the variance. If you found the variance, then you wouldn't want to square. Right? But this time we have the standard deviation, so squared.
And over 35 point question mark 18.
Then.
See, Jesse's timing's off too, because that wasn't really funny.
Then you do N, or no,
Yeah. N minus 1.
you do the,
It's the exact same thing. What's the only thing that changes for the second one?
X.
The left.
XR. or
The
X-
chi, alright, the bottom. So it's 18 minus 1 times 0.253 squared
This one's 5.69.
over 5.697. Somebody do the math on the left, do the math on the right. And again, instead of writing it this way, we'll write it as just a parentheses, just because you guys seem to like that better.
You have to do the square root of them.
Now, when you do this, what I would normally do on my calculator, number one, I wouldn't do 18 minus 1 on my calculator. I'd do that in my head. And I'd just say 17 times 0.253 squared, hit enter, and then hit divided by whatever the bottom number is. Instead of trying to stick it all in there at once, because that just messes stuff up sometimes. So do all the top. 0.03 what?
0.030.
Does anybody agree with that? 0.030 on the left?
I agree.
Anybody get the right yet?
190.
Anybody agree with that? What can you tell me? Is that feasible? Sean, you know what feasible means?
Did you say 0.190?
Yeah.
Oh, 0.190, sorry. Is that feasible?
Yeah, I agree.
Yeah, this number should be what? Smaller than this number, all right? And sort of what we're saying here is this is 0.03, that's 0.19, in that range. Now, what are you gonna do to find the sigma, or the standard deviation?
You're gonna do some square roots.
You're gonna take those two numbers and square root them. What should happen when you take the square root of something like 0.03?
It gets big.
It's gonna get bigger. So your number's gonna be bigger than 0.03. So you take the square root of 0.03. What do you come up with? 1732, so we'll just say 173, that's close enough. Square root of 0.190. Four, 3, 5, 8. So 4, 3, 6, we'll say. See something different.
Yeah, I'm not lying.
So what's the-
0.0361?
So let's try this one again then.
I got it.
0.190 squared.
What did you get, sir?
You got something different?
Wait, are you doing square or square root?
Or square root, I'm sorry, I said squared there. Taking the square root of that, that's what we did wrong. Taking the square root. Yeah, I said square, that's what we did.
I just,
Taking the square root.
okay.
Does that make sense? What's that telling us? Somebody explain that to me. So we're making, we're back to our boozles, right? And we're making our boozles again for this car. We want to be with a 99% confidence interval. We want our boozles to be in a certain range. That right there is telling us the standard deviation, how much off we could be to be in that range. So maybe our boozle's gotta be a certain length, and we're saying we could be .173 down this way or up .436 the other way. We gotta be within that range for it to work right. Pick me another one and we'll do it real quick. 24.
Else.
It's 24 one, does it have a list?
Oh,
It,
okay.
it doesn't matter if it's got a list or not, but I'm just asking. No, do you wanna do another one with a list?
Lists are painful. Why not?
How many problems are gonna be on the test?
50.
'Cause that took forever.
Yeah, it shouldn't, so this next one shouldn't take that long. Took forever because Jacob said, I'm tapping out, and you said, my brain quit working. That's why it takes forever. 15? 15, they give us a stem and leaf. Probably the first thing I would do on 15 is list out those numbers, so somebody help me out. If you want this one not take forever, Jesse, then what should you be doing?
69.
Helping. First number is what?
69.
Second number?
74.
Second number, or third number?
80, I guess. Yeah.
Next one.
90. 99. 99. They don't have a zero next to it, so I don't know if
There's, it's blank.
It's blank, so there is no numbers in that range.
Oh, well then delete 80. No. Oh, wait. And then there's a 112. 136. 139. 149.
Why don't they just write the number?
150.
You know what I mean?
Is that all of them?
Yeah.
Now, what are we gonna have to do with this? Put it in a list, grab your calculator. I'll use my new calculator this time, Dalton, so we can see if there's a reason. 69, 74, 90, 99, 99, 112, 36, 139. Oops. Okay. 139. 150. We should have 1, 2, 3, 4, 5, 10 numbers. Is that right? So I got mine in my list. Now what am I gonna do?
Second or no stat.
Stat. Go to calculate, 1 bars. Put in your list.
The S is 30.243.
Anybody else agree with that?
30.243.
We'll just say 30.24, that's close enough. What other things do we need? N equals 10,
What did you guys get?
30.243.
Give me 27.6.
Is this the very
Check your list.
That's what I got too.
You got what?
It's the same as you.
Oh,
I got
did you guys put 112 or 12?
112.
Making sure, because I had to retype mine in. 'Cause I'm
You guys didn't put the 80 in there, right?
Pretty sure I did not.
The 90, was 90 an actual number? Yep.
Was typing in like.
150.
You got 69, 74, 90.
Let me go back and I'll check my list. Let's check them together, go down through your list. 69,
74,
74,
90,
90,
99,
99, 99,
112,
112,
136,
136,
139,
139,
149,
149,
150.
150. That should be it.
See, that's exactly what we got. So I'm gonna do it again.
Would it be best to square the
Make sure you hit the
sigma
right.
so you can just get your
Make sure you
variance
hit the right
off
list.
this?
You could, so
I got 30 points.
if you wanted to square it right now and then plug that number in,
Later on, so you don't have to.
so you don't have to square it then, and you just multiply.
Is this, wait, come here. Not sure. Here we go.
SX, correct?
98.
That's what we're looking for. S.
SX, yeah.
Alright. What's the situation?
Something weird.
Something weird. Maybe he's right over here. He knows something. He's got the handful in his brain. I'm serious, bro.
Push the.
No clue.
Yeah, there's like certain modes.
When you, on this, on the new calculators, and I was using the old one, so when it says frequency list, clear that out.
Clear.
So where it says frequency list, it's gotta be clear.
Why?
Because what it's doing is, it's taking that list and redoing some other math. And now, if you do that, I did yours with list 2 this time, I just repunched it in. But clear that where it says frequency, we don't want anything there. All we want in is the list.
Yeah, I got
We can-
30.24.
Because you clear that out and then it works.
That's probably why I keep getting things.
So maybe you have to make sure some of these that,
Is this
I
the
keep getting,
bearing?
because I was computing it wrong. I keep getting it wrong.
that's the population standard deviation. But we're not dealing with
I
the
do it
population.
exactly we're supposed to.
Remember, you have a different S and you have a different sigma. Sigma stands for the population, S stands for the sample. But we don't have the population. That's the whole point of all of this chapter is, we don't know the population because we can't survey every single person.
So the only thing that you can use out of this is the.
For now is the S. Right? And Nick said this, and we can do this, and you can do this when you're doing it. You could take this number right now and do what to it? Square it. Somebody tell me what 30.24 squared is.
914.46.
914 we'll say 914.5, close enough. Now, when we get down here and we start doing the intervals, we can just put that in and not square it, not have to do that squaring when we're doing all that math. If that's the way you want to do it, that's fine. Pick one way or the other though, so that you don't confuse yourself. All right? Next thing, what else we gotta find? DF, what is DF? 9, what else?
X.
Chi-squared right, chi-squared left. How are we gonna find the chi-squareds?
Wood minus
The C, which we don't have. The C.
We don't have the C, what'd they tell us?
It's 98.
98? Is that what they said?
What is it?
We're on 11.
No, we're on
15.
15.
98.
98? So we're gonna do 1 minus 0.98 divided by 2, and we're gonna do 1 plus 0.98 divided by 2.
0.51, the minus
0.51? That sure,
0.51.
I got
That-
0.01.
that sure don't sound right.
What? Well, I got 0.99 or plus.
Yeah. So.
Alright, again, you guys using your calculators wrong. See, I was hoping I wouldn't have to explain this. Grab your calculator, 1 minus 0.98, grab your calculator, don't, 1 minus 0.98
Equal.
equals,
With line-
divided by 2.
0.01.
You gotta explain that to them. You guys know better. Do this one, 1 plus 0.98
That one's 0.99.
equals 0.99?
Yeah, that's what I was trying to say.
No.
What I'm talking about.
Well then stay where we're at.
I told you which one I was talking
No,
about.
you,
Me and Jacob.
now what do we do?
chart.
Use the chart. 9.01. So you guys are complaining about these taking a long time. They take a long time because all the silliness.
2 point, stop, hold on, 21.666. Dear God.
Then what? What's the left one? Use 9 and 0.99.
2.088.
Everybody agree with those two?
Yep.
Now, and I'm not gonna write all this out this time, let's just, we got this. On this one, we want n minus 1, well, what is n minus 1? We just found it, 9. Times, and if you're using what Nick said, what could we just put in there?
Just put 9.
Put 940, or 914, sorry, 0.5. What's gonna be over here on top?
The same thing.
Same thing, 9 times 914.5. This is your n minus 1 times your standard deviation. N minus 1 times your standard deviation. What goes on bottom of this one? 21.666. And what goes on bottom of this one? 2.088. Somebody tell me what you got for the left side. $379, we'll say 379.9, close enough. Everybody agree with that?
Yeah.
How about on the right side?
I got that.
Now, this is the interval for our what? That's for our variance. We still gotta find the interval for what? Standard deviation. How do we find that? Take square root of this number. Somebody tell me what that is. I look at 379, I know it's gotta be like 19 or so. 19.49, we'll say 19.5, close enough. Then you take the square root of 3,941, that's probably somewhere, I don't even know,
62.
62.8. These are your two answers. Interval for your variance, interval for your standard deviation. Do what? And once you do one or two of them, doesn't take as long because once you know the process. If you didn't write this down last time, this is what you gotta do to write those. First, it's gotta be normal. This just tells you step by step. Second, you gotta find your DF. Third thing, you find your S squared. Now, are we gonna use this formula to find our S squared?
No.
Probably not. Alright, normally to find S squared, this is the formula that we used at the start of the year with that big long chart where we had to make all the columns and we had to add them all up and everything. We're probably not gonna use that right now. How are we gonna find S squared? Either use the calculator or they're gonna tell you. Sometimes they'll tell you the standard deviation or the variance. Number 4, find the critical values. To find the critical values, we use the chart. Use the chart, use your DF and what else do we need besides, oh, and your C. So on this, use the DF and the C. You gotta find those areas. Number 5, do that formula, the two sides, to find your interval for your variance. This is the variance interval. Sorry, I'll be out of the way in 1 second. This is the variance interval. And then once we do that, what do? Take the square root, and that's our standard deviation, interval.
I'm ready for the test.
So let's take it right now. I'll read it this
We
weekend.
got like, not very.
That's all right.
I could start it today.
I'll grade what you get done. Just mark the rest of it wrong, that makes it easy.
That's not even fair. I can take it home, I'll bring it back to you.
No, because
Slater wouldn't do it for you because it's
I
not out,
wouldn't do, I don't even use Slater, I told you
it's
that.
not out of the book.
I would not cheat.
Slater only does stuff that's in a certain book.
Would you trust me to take it home and tell you I'm not gonna cheat on it?
See, it always kills me, Jacob, that a lot of these teenagers don't have a clue that I actually know these things. And I've been on those websites before.
No, what I'm saying, would you trust me to take it home and not cheat on it?
No.
Really? You wouldn't even trust me? I really wouldn't cheat if I told you I would. I would.
I bet if I like to take it home, you still wouldn't get it.
I probably wouldn't, cause I wouldn't cheat.
how we find it, Brooks probably has it.
Does everybody have that much? Carson, you handle all that?
Yeah.
A little easier now? Don't lie, it's not easier. Just might know it a little better.
Yeah, it's not the same.
So you're a little smarter now, maybe.
Yeah, put it that way. It just takes on. Okay.
That's the old assignment. This is the actual new assignment.
Did you look at that?
What? As far as what you did? No. I'm gonna look at this next one. So this will be your grade for this section. As soon as I figure out what I did with it.
Where's the?
Yeah, that didn't look good. Page 341. Problems. Due Tuesday.
Today's Friday.
Yeah. It's brutal. Not really.
I'm just.
Make sure on this one, I'll probably, when we come in here, I'll probably just collect this one.
I don't know what wrong.
What's the stick?
It's like a six. It makes me sad.
Yeah, we can figure it out next, like, this following Monday.
It's one Monday.
Keep paying. His car. Right in Newport.
I like your class. I had tried it, but I
Sign
I don't
this.
know what's wrong, man.
If you get there, he'll figure it out.
I don't miss your classes. I don't
Today's
miss
the
this.
last day that the guy that has the accounting has.
I could call him and explain it to him, he'd probably be like, whoa, check this.
Dude, you're going fast, bro.
Is that Monday?
What you guys doing?
We got my tooth jacked up.
Working on that
Really
paper.
weird.
I always hear that, man. My dad.
I can show you my source Monday.
He didn't know that.
Are you?
Yeah, it's like
are you
sources.
sure
You have to put my sources.
Okay, I'll
Well,
put
it's not
it
even
in
taking-
your
it's like 50 points.
Yeah, he
Sources
started
for
like
what? Like,
hacking AK-47, like, it's like just hacking him into his car. His was on the side. I was like,
Make sure on this assignment, Sean's gonna put it off till Monday night. Is he gonna remember any of that stuff that we just did?
Oh, he's probably got
No,
notes.
I'm sorry, but that's the way you guys
I
are.
got my
You
notes.
put it off till then, you'll remember none of it. And then he says, that's why I got my notes. And he'll look back at his notes and it'll all look like Greek to him. Because it is. Chi and all that stuff is Greek. But it'll look even more like Greek to him because he won't understand any of it. Because it.
I remember it.
Hey.
Or you got recording?
Is he really that good with car stuff?